Hello everyone, Mr. Miller here. Hope that you're doing well. This is the second recording I'm making this half term for the two papers I've given you, paper 2 and paper 3, which is this one of the November 2017 Edexcel series. Again, a fairly tricky paper here, quite a few difficult questions, so let's go through it. Okay, here is question 1, and it gives us a table showing information about the heights of 80 children. And part A says, find the class interval that contains the median. Okay, so the median I know is the middle number. So I've got 80 children in total. So the middle child is going to be the 40th child. So let's go through the frequency table. Is it in the first category? No, because there's only 4. What about the second one? Well, that goes up to 15. Because 4 plus 11 is 15, so it's not in there. The third one, 24, well, 15 plus 24 is 39. So there's 39 pieces of data in the first 3, so median is not quite in that one. But if I add another 22, I get 61. So I've gone past 40, therefore it is in that one there. So I'm going to write that fourth group there. Okay, part B, draw a frequency polygon. Okay, so frequency polygon, what do we do here? Well, on the x-axis height, we need to plot the midpoints. So let's just do that in our table. And fairly straightforward to find the midpoints. So I'm going to plot the midpoints on the x-axis, and on the y-axis, I'm just going to plot the frequency. So the first one is 135 and 4, which is here. Then 145 and 11, 155 and 24, and so on. Okay, once you've done that, you're going to get your ruler. You're going to draw a straight line in between all of these points. So I'm not using a ruler, but you definitely need to. No curve, just a straight line between all points. That is all you need to do. So let's move on to question 2. Okay, question 2. In London, 1 litre of petrol costs 108.9p. In New York, 1 US gallon costs $2.83. We're then told some conversions, and we're asked, in which city is petrol better value for money, London or New York? Okay, so we know that with these types of conversion questions, I need to convert both of these into the same amount, so litres or gallons, and the same currency, so pounds or dollars. And there's a number of ways you could do it. So you could convert everything into litres and p, in gallons and dollars, or any combination. But I actually think that if we start off with the London ratio, 1 litre will cost us 108.9p. And I think we can work out how much it would cost in London for 1 gallon in dollars. So how much would it cost to get 1 US gallon? Well, to get from litres to gallons, I'm going to need to multiply by 3.785 because 1 gallon is more petrol. So I'm going to need to pay more. That's one way to think about it. So if you do that, the cost in pence is 412.1865 pence. So that's how much in London 1 US gallon would cost in pence. But of course, to compare it to the New York price, we need to convert that into dollars. So 1 US gallon, let's think about what I need to do here. Well, for every £1, we need to spend $1.46. So again, I'm going to need to multiply this by $1.46. And I get 601.79. That's now going to be in cents. And this is the same as $6.02 to the nearest cent. And because this is much greater than the US price, we can say that New York is better value for money. So we've got 1 US gallon in cents in the London prices. Compare that to the New York prices and we get our answer. Okay, question 3. A gold bar has a mass of 12.5 kilograms. The density of gold is 19.3 grams per centimeters cubed. Work out the volume of the gold bar. Okay, so I think this is a mass density volume question. So I'm going to draw my triangle with Miller on top. And I need to work out the volume. So my equation for volume is going to be mass over density. Now, I need to be a little bit careful here and have a look at my units. So my mass is in kilograms, my density is in grams per centimeters cubed, and I want my volume, looking at my answer line, to be in centimeters cubed. So I think I'm going to need to convert my kilograms here into grams, because my density is in grams per centimeters cubed. So how do I do that? Well, hopefully you remember that there are 1,000 grams in each kilogram. So if we multiply this by 1,000, we're going to get 12,500 grams. Substitute that into my formula. Put that into your calculator. In your calculator, you get 647.668, etc. But 3 significant figures. So we look at the third significant figure, which is the 7. We look after that, which is 6. So that 7 rounds up to 648. Next question. Okay, there are only blue pens, green pens, and red pens in a box. The ratio of number of blue to the number of green is 2 to 5. So I'm going to write straight away blue to green and then 2 to 5. Then it says the ratio of number of green pens to number of red pens is 4 to 1. Okay, so green to red, I'm going to write 4 to 1. And I can immediately see that the number of green pens is different. Then it says there are less than 100 pens in the box. What is the greatest possible number of red pens in the box? Okay, so before I go any further, I think I'm going to need to change this ratio so that the green parts are the same. So I look at the green parts 5 and 4, and I'm going to multiply them to get 20. And now I'm going to see what my new red pens and my new green pens are worth. So how do I get from 4 to 20? Times by 5. So 1 times by 5 is 5. And then blue pens, well, how do I get from 5 to 20 times by 4? So 2 times by 4 is 8. Okay, so that is my new ratio, 8 to 20 to 5. And now I'm going to add those up. I'm going to add those up so I can see how many parts there are in total. So 8 plus 20 plus 5 gives me a total, so I'm going to write total up here, total number of parts of 33. So how am I going to use this information? Well, there are less than 100 pens, so I think that my total has to be some multiple of 33. So what is the greatest multiple less than 100? Well, I think it's 99. So I think there are 99 pens in total, which means that because 33 times by 3 is 99, I'm now going to multiply all of these ratios by 3. That is 24, 60, and 15. And it asks me for the greatest possible number of red pens, so my answer is 15. Okay, bit of a tricky ratio question. Let's keep going. Question 5, part A. Find the value of the reciprocal of 1.6. Give your answer as a decimal. So I know that when it says reciprocal, that means 1 over that number. So in your calculator, 1 over 1.6. and then you're going to change that to a decimal, which is 0.625. Part B, just round the number x to one decimal place. The result is 9.8. Write down the error interval for x. Okay, so error interval, I know I need to do my error interval diagram. 9.8 in the middle, one decimal place. So I look at that first decimal place, which is 8. I go up 1, and I go down 1. And in the middle, I'm going to get the two numbers that I will use. Now I need to write this as an error interval. So you need to remember how to do this. And error intervals are always written like this. And the way to remember this first one, x is bigger than or equal to 9.75. And the reason why it's that is because if the number x was 9.75, that would round up to 9.8. But the number can't be 9.85 because that would round up to 9.9. So those are always the inequality signs that you need to write your error interval. Next question. Okay, here is a rectangle. It says the length of the rectangle is 7 centimeters longer than the width. Okay, 4 of these rectangles are used to make this 8-sided shape, and it tells me that the perimeter is 70, asks me for the area. 5 marks here. Okay, so immediately what I look at is that the question is not giving me any dimensions. And I think it would make sense to call the smaller side, i.e. the width, x. And if I use some algebra here, I can make an equation and solve it. So if the width is x, what is the length? Well, 7 centimeters longer, x plus 7. Okay, so now I look at the diagram below, and I'm going to put on all of my dimensions here. So let's start off at the bottom here. So this is x plus 7. This is x. This is x plus 7. Now, what about this length here? Let's change to blue. I need to do some thinking about this here. So if I think about what that length is, that is the longer length, which is x plus 7, subtract this shorter length, which is x. So x plus 7 minus x, well, the x's cancel out, and I'm just left with 7. So that weird length there is 7. And let's keep going around the shape. So x here, and I've got another length here, which is 7. And then this here is x. Okay, so perimeter, let's get my highlighter out. I'm going to highlight all of the lengths that are part of the perimeter. And let's count up carefully what I've got here. And it's easy to make a mistake. When I first did this question, I made a mistake, so don't rush this. Let's count up how many x's I've got. So I've got 1, 2, 3, 4, 5, 6, 7, 8. 8x. Now, how many 7s have I got? 1, 2, 3, 4, 5, 6. 6 7s is 42. And I know that the perimeter is equal to 70. So I think I can now solve this equation. And you get a decimal as your value of x. You get 3.5. So we're almost there. I need to work out the area. Well, to work out the area, I think I need to work out what the dimensions are. So let's go back to the original shape. I know that x is 3.5. And x plus 7, well, that is 3.5 plus 7, which is 10.5. So the area of one of these rectangles is 10.5 times 3.5. which is this. But how many of these shapes do I have? I've got 4 of them. So I need to multiply this by 4, and I get an answer of 147. Okay, nice question, that one. Let's move on to question number 7. Okay, question 7 is just a standard form question, and it asks me to work out this thing, give your answer as an ordinary number. So ordinary means not in standard form. So remember, you've got a calculator for this, so you can just type this into your calculator. You don't need to do any working out. But when you type it into your calculator, for me, it gave me this. And this is not in ordinary form, this is in standard form. So how do I convert this into standard form? Well, because it's 10 to the power of -4, I'm going to move back my decimal place 4 points. So 1, 2, 3, 4. Fill in my placeholder zeros, and I'm going to write that out again. And that gave me my answer. Next question. Question 8. When a drawing pin is dropped, it can land point down or point up. Okay, Lucy, Mel, and Tom each dropped the drawing pin a number of times. Table shows the number of times the drawing pin landed point up, number of times the drawing pin landed point up for each person. Okay, so it gives me 3 people. It gives me the number of times it's point up and point down. And it says Rachel is going to drop the drawing pin once. Whose results, so who, will give the best estimate for the probability that the drawing pin will land point up? Give a reason for your answer. Okay, so whenever you get this kind of question, and we've seen this in class, all you need to look at is who has thrown it the most number of times. Because the more trials that you've done, the more reliable your estimate is. And you can see quite clearly if you add up the number of times each of them have thrown it. So Lucy, it is 45, Mel, it is 80, Tom, it is 25, Mel is the most. So you're going to write Mel, she has, you can say done the most number of trials. Okay, then it says Stuart is going to drop the drawing pin twice. Use all the results in the table to work out an estimate for the probability that the drawing pin will land point up the first time and point down the second time. Okay, so my first step is to find, using all the results in the table, what the probability is that it will land point down and point up. So if I add together all of the results for point down, 31 plus 53 plus 16, I get 100. And same thing for point up, I get 50. So those are my totals. What is the probability that the drawing pin will land point up? Well, there are 50 times it lands point up out of a total of 150, because that's 100 plus 50. That we can simplify to 1/3. And then point down, that is 100 over 150, which is 2/3. So how do I work out the probability it lands point up and then point down? Well, remember, to find 2 probabilities in a row, you multiply the probabilities. So you're going to do 1/3 times 2/3 to get 2/9. And that is your answer. Let's keep going. Okay, question 9. Jack bought a new boat for £12,500. The value V of Jack's boat at the end of n years is given by this formula. Okay, at the end of how many years, so my answer needs to be a number of years, was the value of Jack's boat first less than 50% of the value of the boat when it was new? Okay, so let's figure out what that value is. So 50% of the starting value is 6250. So I need to see when is the value first less than 6250. Okay, so what do I do? So let's have a look at this formula where n is the number of years. So if n is 1, that is after 1 year, the value is going to be 12,500 times by 0.85 to the power of 1. In your calculator, you get 10,625. So after 1 year, it's that amount, which is not less than 6250. Now, let's keep on going. So when n is 2, you're going to substitute n is 2. And you get this. Still not less than 6250. And if you keep on doing it, you're going to get your answer. So put in all of these in your calculator. So that after 4 years, it's not quite less than 6250, but when n is 5, it was 5546. So you're going to say 5 years, because that is when your value is less than, so I can write that 5546 is less than half the starting value of the boat. Okay, next question. This is actually part B of the question. So a savings account pays an interest at a rate of R% per year. Jack invests 5,500 in the account for 1 year. Okay, only 1 year. At the end of the year, Jack pays tax on the interest at a rate of 40%. So the tax is 40%. After paying tax, he gets £79.20. Okay, so after paying tax, he gets 79.20. So what does that mean? Well, if he's taxed 40%, that means he gets the other 60%. So after paying tax, i.e. 60%, is equivalent to £79.20 because the tax was 40%. So the original amount of interest that he gets, I want is 100%. Well, how do I get there? I can find out what 10% is first by dividing by 6 and then timesing by 10. So if you do this, 10% was £13.20 and 100% was £132. So £132 was the interest. Now we need to find out what that is in terms of a rate. So the way to do this, if you do your scale factor model, you know that the original amount was 5,500. What is the new amount? Well, that is going to be 5,500 plus the interest, because you know how much interest he gets, which was 5632. And you want to find out that interest rate times by y. So how do you find out that interest rate? Well, you can set up an equation. We've done this kind of question before. Divide by 5,500. And we get y equals 1.024. And so I need to find out what that is in an interest rate. We've seen lots of these types of questions in past papers where we need to turn a scale factor into an interest rate. So I know that that is 2.4% interest. And the reason why is because if you think about what 2% interest would be, 2% would be 1.02. So 1.024 is just going to be 2.4%. Again, we will have a look at percentages again in detail in class. We'll spend a few lessons on it. But this kind of question we've seen a few times before. Okay, question 10. There are only blue counters, yellow counters, green counters, and red counters in a bag. A counter is taken at random. Table shows the probabilities of getting the counters. Part A, work out the probability of getting a red counter. Okay, so this is fairly straightforward. Just going to add up the probabilities that I know. And we know that probabilities sum to 1. So I'm just going to do 1 minus 0.95, and I get 0.05. And that is my answer. Also write that in the table. Part B. What is the least possible number of counters in the bag? You must give a reason for your answer. Okay, so this is a problem-solving type of question. There's actually a number of different ways to think about it. One way to think about it is if I write out all of these probabilities again, and then what I'm going to do is I'm going to turn that into a ratio with a whole number. So if I multiply all of these by 10, what do I get? I get 2, I get 3.5, I get 4, and I get 0.5. We can't have that because we can't have half of a counter. But if I now multiply by 2, 4, 7, 8, and 1. So I've expressed my counters as ratios. And the reason why this is the smallest possible number is because I can't simplify this any further. So I have 4 blue, 7 yellow, 8 green, and 1 red. Those sum up to 20. And the reason is, as I can't simplify the ratio any further. That's one way of going about it. Okay, let's move on to the next question. Okay, question 11. A cumulative frequency graph shows information about the weights of 60 potatoes. Part A, use the graph to find an estimate for the median weight. Okay, again, median weight means the middle number. So that is the 30th potato. So we need to go across from 30 using a ruler and down. And if you read off the graph, that is 57. Okay. Jamil says 80 minus 40 is 40, so the range of the weights is 40. Is Jamil correct? Okay, this is a little bit of an interesting question. I can see that the biggest weight is 80 and the smallest weight of 40. So the range could be 40. But do you remember with cumulative frequency graphs, you are often given the data as grouped data. So for example, the first group could be 40 to 50, for example. And you have to start the frequency diagram at 40, but it doesn't mean that there is a weight which is exactly 40. The smallest weight could be 41 or 42 or 43, etc. So I'm going to say he's not necessarily correct. Not necessarily. He could be correct, but he's not necessarily correct. The smallest weight could be more than 40 as the data is usually grouped for cumulative frequency diagrams. Okay, part C. Show that less than 25% of the potatoes have a weight greater than 65 grams. Okay, so I think my first step is to find how many potatoes do have a weight greater than 65 grams. So I'm going to find 65 grams, go up using a ruler, go across, very messy, but that gives me 49. So how many potatoes do have a weight greater than 49? Well, I need to do 40 minus 60 minus 49, which is 11. So 11 potatoes have a weight greater than 65. What is that as a percentage? Because I want to show it's less than 25%. Well, it's 11 out of the total number of potatoes times by 100 to make it into a percent. And that in your calculator gives you 18.3%, which is obviously less than 25%. And that is what you would need to do. Okay, next question. Question 12. Alan has two spinners, spinner A and spinner B. Each spinner can land on only red or white. Okay. It tells me the probabilities, and actually the diagram is completed for us. So he says spins A once and B once. Okay, does this a number of times. The number of times both spinners land on red is 24. Okay, both spinners land on red is 24. Work out an estimate for the number of times both spinners land on white. Okay, so how am I going to start this problem? I think I'm going to start this problem by working out the probability that both spinners land on red. So probability of red is going to be 0.25 times by 0.6, which is 3/20 as a fraction. That's what it gave me in my calculator. Now, if the probability of that is 3/20ths, and I do that a number of times, I can say that 3/20ths times by my number of trials, let's call that n, is equal to 24. And I need to find out what that n, the number of trials, is. So to solve this equation, I can times by 20 and divide by 3. So n is 160. And that makes sense because 3/20ths times 160 is equal to 24. Now that I got the number of times he spins both spinners, it now tells me to work out the number of times both spinners land on white. So I'm going to do white, 0.75 times 0.4, which is 3/10. And I now need to do 3/10 multiplied by 160, which is 48. And that gives me my answer. Okay, next question. Question 30. Write x squared plus 6x minus 7 in the form x plus a all squared plus b. So I know when I see this written, that means I need to complete the square. So we did this fairly recently. What am I going to do? Well, I'm going to do x plus 3, because 3 is half of 6. And I need to do minus 3 squared, which is 9. Also minus the 7. So I get x plus 3 squared minus 16. And that is my answer. Fairly straightforward question if you remember how to complete the square. Okay, question 14. Cone A and cone B are mathematically similar. The ratio of the volume to cone A to the volume of cone B is 27:8. Tells us the surface area of cone A. Show that the surface area of cone B is 132. Okay, so again, we did this last year, haven't done it much recently, so we will recap it. And what I told you to do last year, and what I'm going to remind you to do this year, is to draw out a table. So the table that you need to draw out, your two cones, A and B, your scale factor, and your length, your surface area, and your volume. Okay, let's see the information we've been given. So we've been given the ratio of the volumes, which is 27:8. Those aren't your actual volumes, but that's the ratio, which you're going to use to find out your scale factor. And you're given the surface area of A. So what can you work out? I think you can work out your scale factor from A to B. So how do I get from 27 to 8 times by 8/27? Okay, so I need my scale factor for surface area, but first, do you remember that I need to go back by cube rooting it to find my length scale factor? So the cubed root of 8/27 is 2/3. And now, how do I get my surface area scale factor? I'm going to square that. So when I square that, I get 4/9. And now, to find out your surface area of B, you times that by your scale factor. And when you put 297 times 4 ninths into your calculator, you do indeed get 132 centimeters squared, which is what we want. Okay, next question. Okay, so this is an iteration question. We're going to recap it in school very, very soon. It's actually 9 marks here. So let's have a look at it. So part A, show that the equation has a solution between x equals 0 and x equals 1. So to do this, you're going to do x equals 0 and x equals 1 and plug that into your equation. So 0 cubed plus 7 times 0 minus 5 gives you minus 5. And for x equals 1, substitute x equals 1 and you get 3. And you need to say, since there is a change of sign, what that means is one of the answers is negative, one of the answers is positive, there is a solution. Okay, part B, show that the equation can be rearranged to give this thing here. So let's start off with my equation. And I need to somehow rearrange it to give what we've got on the right-hand side. So the first thing I see is that the equation that I want has this positive 5 on the numerator. So I think I'm going to want to move that minus 5 onto the right-hand side. Okay, now what am I going to do next? Well, I can see that my answer has x equals something. So why don't I try to factorize out an x from the left-hand side? If I do that, I'm left with x squared plus 7, and that's useful because that's what I've got in the denominator. So when I divide both sides by x squared plus 7, I actually get to my answer, which is 5 over x squared plus 7, which is what I want. Okay, part C. Starting with x equals 0, use the iteration formula 3 times to find an estimate for the solution. Okay, so I start off with x equals 1. That's going to be the first thing that I plug into my formula. So to get my next answer, I'm going to look at my formula, which is 5 over xn. Well, I'm going to use 1 for that. And pop that into your calculator, and you get 5 over 8, or 0.625. Okay, need to do this a couple more times because it asks me to do it 3 times. So to x2, you can get x2, you can do the same thing, but this time you're going to use 0.25 squared, and you are going to get this thing here, fraction there, and do it one more time. And what I'll show you in class is that it's very easy to do this using your answer button. You're going to get 0.670. That is your x3. Okay, part D. By substituting your answer to part C into x cubed plus 7x minus 5, comment on the accuracy of your estimate. Okay, so what I need to do is I need to substitute my answer into my formula. So I'm going to do 0.670 cubed plus 7 times 0.670 minus 5. If you put that into your calculator, you get minus 0.00549. Now that is very, very, very close to 0, which is what you want. And what I'll be explaining to you is that using this iteration thing is actually a way that we can solve equations that are difficult to solve. by getting a good estimate. So we're going to say this is very close to 0. So it is a good estimate. So that is the iteration question for 9 marks. Okay, let's keep going. Question 16. The petrol consumption of a car in litres per 100 kilometers is given by this formula. Okay, Nathan's car travelled 148 kilometers, correct to 3SF. Okay, so this looks like a bounds question because it says correct to 3SF. We're also told how much petrol it used. And Nathan says, my car used less than 8 litres of petrol per 100 kilometers. Could Nathan be wrong? Okay, so my first thing is to find out my bounds. So I need to find out my bounds for the kilometers it travels and the litres it uses. So I can do that fairly straightforwardly. We've done lots of this, practicing this in class, so we should all be feeling confident. So let's go back to the question. My car used less than 8 litres of petrol per 100 kilometers. So in order for us to show that he might be wrong, we need to see, could it have been more than 8 litres? So I think that we need to find the upper bound for petrol consumption. So what is that upper bound? We're going to do 100 times by the number of litres of petrol used. So the upper bound, 11.85, divided by my lower bound for kilometres, 147.5. This upper bound is equal to 8.03, which is more than 8, so we need to say, yes, he could be wrong. Because if we took the upper bound, the car has used more than 8 litres of petrol. Okay, next question, question 17. We've got 2 triangles, ABC and ADC. Neither of them are right angles, so looks like we could be using the sine rule, cosine rule, something like that. It tells us that the area of triangle ADC is 56. So ADC is 56, and I want to work out the length of AB. Okay, I want to work out the length AB. Let's call that X. And let's figure out what we're going to do here. So the first thing I am going to do is I'm going to use the information that the area of triangle ADC is 56. And I know the formula for area of a triangle is a half AB sine theta. So let's have a look at this triangle. What do I have here? Well, I've got one of the sides, 11. Let's call that A. I don't have this side here. Let's call that B, but I do have theta, 105. So I think step 1, I can set up a formula for area of the triangle, was that half times 11 times B times by sine 105, and I'm going to make that equal to 56. So this is now an equation I can solve. My first step, let's get rid of that 2 on the denominator, so times both sides by 2. 11b sine 105 equals 112. And now to get b, I need to divide by all the coefficient of b. So 11 sine 105. Divide by 11 sine 105. So pop that into your calculator, and you get 10.541. We're not going to round it too early. Okay, that's step 1. I've worked out what b is. B is equal to 10.541. Step 2. Okay, now that I know this length B or CD, I'm thinking, what else can I find? Well, if I have a look at triangle ADC, I now know 2 sides and the angle in between. So I think, because I know the 2 sides and the angle in between, this is an angle sandwich, I can use the cosine rule. And I'm going to use the cosine rule to find out this side length y, AC. So let's write out the cosine rule. A squared equals b squared plus c squared minus 2bc cos A. And let's label on the sides. So A is the side opposite the angle. That big A is the angle. And then B and C are the other two sides. So I've got y squared equals 10.541 squared plus 11 squared minus 2 times B times C times by cos 105. And if you type all of the right-hand side into your calculator, you get y squared equals 292.133. Square root that, you get 17.092. So let's add that on. Y is equal to 17.092. Now, probably quite close to getting the answer because I've done two things already. Let's have a look now at triangle ABC. And I can see I've got this side, this angle opposite, and another angle, and I need to work out that side opposite. So I think that now I can use my cosine rule, not my cosine rule, my sine rule, to find out that angle, that side length x. So my sine rule, A over sine A equals B over sine B. And let's label on those things. So this is going to be A. This is going to be big A, that 48. This side Y I'm going to call B. And angle B is 118. So x over sine 48 equals 17.092 over sine 118. And to get my answer x, I'm going to multiply by sine 48. So I have x equals 17.092 times by sine 48 over sine 118. And I get my answer to one decimal place, which is 14.4. So a nice question, that one. I had to use both the cosine rule and the sine rule, and starting off with the area of a triangle. So quite a lot to do that, but it was worth 5 marks. Okay, let's keep on going. Okay, question 18. Here is a speed time graph for a train. Work out an estimate for the distance the train traveled in the first 20 seconds. Use 4 strips of equal width. Okay, so I'm going up to 20. And I want 4 strips, so 20 divided by 4 is 5. So I'm going to form my 4 shapes, A, B, C, and D. Shape A looks like a triangle, and B, C, and D look like trapezium. So I'm just going to write down my formulae. So triangle, my area is base times height over 2, and my trapezium, add the parallel sides times by the height divided by 2. Okay, so A, first of all, my triangle, well, my base is 5. My height looks like 2. Divide that by 2 and I get 5. B, well, I'm going to add my 2 parallel sides. They are, this one is 2 and this one is 5. So 2 plus 5 times by my height. Now the height for all these trapeziums is going to be 5. Divide that by 2 and I get 17.5. C, well, this is 10. So I'm going to do 5 plus 10 times by 5 divided by 2, which is 37.5. And finally D, this looks like it is 18. So 10 plus 18 times by 5 divided by 2 to get 17. So add up all of those numbers and I'm going to get 130. Okay, part B. Is your answer to A an underestimate or an overestimate of the actual distance? Well, here, let's have a look at the bits that I have counted. So these extra bits I have counted in my area because they were part of the trapezium, but they're not actually the area under the graph. So actually what I've got here is I've got an overestimate, as there is some extra area that is not actually under the graph, something like that. Those bits there highlighted, I have counted, but I shouldn't have because they're not actually underneath that curved line. Okay, let's keep going. Question 19. Prove algebraically that the straight line with equation x minus 2y equals 10 is a tangent to the circle. Okay, so I think this is 5 marks here. This kind of question is a simultaneous equation question. And if you think about what this actually means, let's draw a circle and let's draw a tangent to that. If I do have a tangent, then they meet at one point. And if they meet at one point, that means I've got one solution. So that's what I want to try and show. So my first step, I'm going to take my linear equation and I'm going to rearrange to make x equals or y equals. Now I think it's a lot easier to do this. It's a lot easier to make x the subject, because if I made y the subject, I would get a fraction, and I don't want that. It's going to make my life difficult. So that's step one. I'm now going to substitute that in to my quadratic simultaneous equation. So instead of x squared, I'm going to write 10 plus 2y squared. Plus y squared equals 20. Let's do a box up here. So that's going to give me 4y squared plus 40y plus 100 plus y squared equals 20. Let's collect like terms. And because this is a quadratic, I'm going to make everything equal to 0. Okay, now I need to solve this quadratic equation, and to do this, can you spot a shortcut? Well, I can. I think if I divide everything by 5, it's going to make my life a lot easier. So this is the quadratic equation that I now have. And I now can factorize this because I'm looking for two numbers that multiply to give 16 and add to give 8. And hopefully you can see that that is 4 and 4. And that is good news because both y1 and y2 are equal to minus 4. And that's good because I only wanted one possible answer for y. I can also find my x values, which are going to be the same. So x is 10 plus 2y. So 10 plus 2 times minus 4, which is 2. x2 is going to be the same. And I should probably say, as there is only one solution, the line is a tangent to the circle. Perfect. Not such a tricky quadratic simultaneous equation to solve there. Let's keep going. A couple more questions to go. Okay, question 20. A, B, and C are points in the circumference of a circle center O. AOB is the diameter. And we want to prove that angle ACB, so that's ACB there, is 90 degrees. You must not use any circle theorems in your proof. Okay, so we did have a look at proving some of these circle theorems, And generally, what you want to try to do here is two things. So I'm just going to get rid of that angle for a moment. What you want to try to do is two things. The first thing you want to do is draw in any other radius that you can see. So I'm going to draw in this radius here, OC, and I can see that all of these sides, OA, OC, OB, are all the same. They're all radii. That's going to be useful in a bit. The second thing that I want to do is I want to try to call an angle x. So let's just pick this angle here to be x. It doesn't matter which one you do, but you probably don't want it to be one that is around that point C. Okay, so if that angle is x, what other angles can you find? Well, you can see that I've got an isosceles triangle here. So I know, because base angles and isosceles are the same, that this angle here is also x. So I'm going to say base angles in an isosceles triangle are the same. And I should probably say, arrow pointing to this one, let angle OBC equals x. I should probably just point that out to the examiner that I'm calling this angle x to start off with. Okay, what else can I find? I think I can now find this angle here, COB. What is that? Well, because angles in a triangle sum to 180, and I know two of the angles, I think this angle is 180 minus 2x. As angles in a triangle sum to 180. Okay, what next? Let's change color. I think I can find this angle here, AOC, because that is on a straight line with that angle 180 minus 2x. So how do I find that angle? Well, the total angles on a straight line sum to 180, but I'm going to subtract the angle that I've already got, which is 180 minus 2x. Now you need to be careful here. When you collect like terms here, 180 minus 180 is just 0, but I've got minus negative 2x, which is the same as 2x. So that angle here is 2x. A reason for that, angles on a straight line sum to 180 degrees. Okay, my final step, let's change to a green here. I think I can now work out both of these two base angles. And I can do that because I know that those angles are the same. So to find out what those angles are, I'm going to do 180, which is the sum of the angles in the triangle, minus 2x, because that's the angle I've already got, and I'm going to divide that by 2, because both of those green angles are the same. What do I do that? What do I do when I get that? 180 divided by 2 is 90, and minus 2x divided by 2 is just minus x. So both of these angles here, 90 minus x, 90 minus x. Okay, can you see the final step in my proof? The final step in my proof is that if I have a look at this whole angle, this purple angle, I'm going to say that ACB equals 90 minus x plus x. And the x's cancel each other out, so that angle is 90 degrees as we wanted it to be. So therefore, ACB equals 90 degrees. And that is my proof. This is a good proof to learn. This is a good proof to practice. You might also get asked to prove some other circle theorems. So my two pieces of advice, first of all, see what radii you can find. Second of all, call an angle x. One more question to go. Let's have a look. Okay, question 21. This is a vector question, last question on the paper, so it is probably going to be quite tricky, and it is, but let's go through it. Now, even if you can't get all the way in this question, you can definitely get a couple of marks. So, OAN, OMB, and APB are straight lines. AN equals 2OA. Okay. M is the midpoint of OB. Okay. OA equals A, OB equals B. Right, let's pause there and let's have a look and see what we can draw on the diagram. So OA, this vector here is A, and OB is B. And because M is the midpoint, I think I can call both of these vectors a half B, because I'm splitting that vector OB in half. The other thing I can work out is this vector AN, because we're told that AN is twice OA. And if OA is just A, then AN is going to be 2A. Okay. AP equals KAB, where K is a scalar quantity. What that means is just a number. And it says that given MPN is a straight line, find the value of K. Okay, so I know that when I've got a straight line, all of the vectors along that straight line are multiples of each other. And let's use that fact later. But before we do that, because we're told that MPN is a straight line, I think we can find some vectors MP, MN, PN. So let's give it a go. The first thing that I think I'm going to need to find is, let's find this vector A to B. Do my working up here. Let's find that vector AB. And the reason I think I'm going to need to find that is because we're told that AP is some number times AB. So it makes sense to find AB first. And that's quite straightforward. To get from A to B, you go from A to O, which is minus A, and then plus B. So therefore, I think you know that A to P is K lots of that. So K lots of minus A plus B, which is minus AK plus KB. Okay, so I know what that vector AP is. Now, let's have a look at this straight line, MPN, and I think there's one vector on that straight line which doesn't involve this weird A to P. So I think that I can find, first of all, this vector MN. Because to get there, I just need to go from M to O, which is minus a half B, and then plus A plus 2A, which is plus 3A. So that is that vector M to N. Now, I'm going to need to find another vector on that line. I think that I want to find P to N. So those are two vectors on that straight line. MN easy, PN more difficult. Okay, so let's think about how we get from P to N. The first thing we're going to have to do is get from P to A, and then we're going to have to go from A to N. So how do we get from P to A? Well, P to A is the reverse of A to P. It's the other direction. So I'm going to take this vector A to P, which is up here, and I'm going to change the signs. So I'm going to say it is KA minus KB, just changing the signs. And AN is straightforward. AN is just 2A. Okay, so let's change color. Let me circle what vectors I've got. I've got this vector M to N, and this vector P to N. Now, before I go any further, what I'm actually going to do, get rid of that, I'm actually going to rewrite P to N as the following. K plus 2A minus K to B. Can you see what I did there? Let me highlight. I've grouped together the two parts of the vector that have an A in it, k and 2. And that's going to be really, really important later on. Okay, so now let's compare these two vectors that I've got. I've got mn and I've got pn. And I know that when I've got a straight line, the scale factor from one part of the vector to the other is the same. Let me explain to you what I mean. So let me rewrite out again mn, but this time I'm going to write my a first. And pn, I'm going to write my a first as it was before. So what does this scale factor that I'm talking about mean? Well, what it means is that the scale factor of getting from A to B is going to be the same. And I can see what it's going to be for m to n. My scale factor, actually a bit easier if we do it the other way around, to get from my B part of the vector to my A part, I'm going to multiply by -6, because -1/2 times by -6 gives me 3. So therefore, for Pn, I'm going to have to do the same thing. I'm going to have to multiply by -6. Therefore, what equation can I now do? Well, if I just have a look at the components of the vectors, so k and k plus 2, all I can say, sorry, not k, be careful, minus k, what I can say is that minus k times by -6 is equal to k plus 2. Now, minus k times -6 is just 6k, and I can solve this equation to find out what k is equal to, which is 2/5. So, very tricky question there. These final questions often are, these vector questions often are. But if you need to rewatch the video, this part of the video to understand this, then that is absolutely a good idea. I'll just repeat the key part of this proof was thinking about the scale factor from my B to my A, or from my A to my B. It is the same in both vectors. If I gave you a simple example, let's say I had the vector A plus 3b and 2a plus 6b, you would know that these vectors are parallel. First of all, because we can see that we just multiply one of them by 2 to get to the other one. But second of all, to get from my A to my B component, it is the same. So that is the idea that we were getting at there. Okay, that is it for that paper. Thanks very much for watching, and good luck with it.